So the inverse trig functions, and we had already just watched the video. Okay, I'm not going to repeat about, talking about that. Here is just summarize. Okay, summarize. So this is a picture for the inverse of sine. Okay, and then the domain for the inverse sine function is from -1 to 1. Okay, and then the range for the inverse function is from what? -pi/2 to pi/2. Okay, and you know why we only have this part? Why? Because for the same function, okay, if we choose everything, it does not satisfy the one-to-one function, the horizontal line test, right? It doesn't test, that, okay? So we only choose what? We only choose a branch, right? Like one circle or like a part of the same function, okay? And then we use what? Y equals x, that line, okay? Inverse functions satisfy their graphs are symmetric with respect to the line y equals x, remember that? So that's how we get the graph for the inverse of the sine function, okay? And then the domain of the inverse sine function is from -1 to 1. Okay, well here, okay, I don't think I'm going to test you about this, okay? So we just watch that, okay? But I want to let us know that there's something we have to know is the derivative of inverse trig functions, okay? So the derivative of the inverse sine function is defined by what? 1 over square root of 1 minus x squared. So I need you to know this. 1 over, okay, once we encounter the inverse sine function, the derivative of it is going to be 1 over 1 minus what? X squared, okay? Here this x cannot be 1 or -1, because if x equals 1 or -1, it will make the denominator equal 0, okay? So here for the derivative, okay, this x must be between what? -1 to 1 with no ending points, okay? Not like the inverse sine function. The derivative, we have to get rid of the two endpoints, -1 and 1, okay? Alright, so this is a inverse sine function, okay? So you briefly know the picture, and then you know the derivative, okay? I would strongly suggest you put on, this on your formula sheet to find the derivative for an inverse sine function. It equals 1 over square root of 1 minus x squared, okay? And then why this is the case, we're not proving that. We just know, oh, this is a congruent, okay? So we remember this, we'll put it on the formula sheet, and once we have to use it, we'll use it, okay? Well, similarly, for the cosine function, okay, we choose part of the cosine function, we do the inverse cosine. So this is a graph for what? Y equals inverse cosine, okay? And we can tell that the domain for the inverse cosine is what? Still from -1 to 1, okay? The range for the inverse cosine is from what? 0 to pi, okay? My graph is too tall, okay? 0 to pi, okay? 0 to pi, right? 0 to pi. And then what I want to know is this. The derivative for inverse cosine is -1 over square root of 1 minus square. So -1 over square root of 1 minus x squared. And then similarly, this x cannot be -1 and 1, so x must be between -1 and 1. Alright? And then for tangent function, okay, we know tangent function looks like this, okay, it looks like this, okay. Well, by using the y equals line symmetry, inverse tangent function has a graph looks like this, okay. So the domain for the inverse tangent is all real numbers. The range of it is from -pi/2 to pi/2, okay. And what I need you to know is the derivative for inverse tangent is 1 over 1 plus x squared. So I'm going to write it down here. So y prime equals 1 over 1 plus x squared. And then there's no restriction for x. Why? Because x squared will always be greater than or equals 0. And then this is 1 there. So the denominator will always be greater than or equals 1. So we don't have to worry about it. It will equal 0 somehow, okay, somewhere, okay. So make sure we know this, okay. So this is for inverse tangent, okay. Alright, so pretty much this entire page, if you print out as notes, okay, you can read through everything in detail, okay. So I'm not going to talk about everything in detail. And in the video, we have already talked about this, okay. So you can just read through this page, okay. But remember, I need you to know this, this and that, and everything is also on the back of this page. Okay, so these are the formulas for the inverse trig functions: inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse secant, inverse what? Cosecant. They are derivatives. Okay, so we're going to use this to do calculations. Okay, to do derivatives, to do calculations. All right. All right. So let's look at our practice questions. Okay. Find the derivatives of these two functions and simplify where possible. Okay. So the first question: y is defined by inverse sine of what? 2x plus 1. Find the derivative of the inverse sine function. How? Are we going to use chain rule or not? No? Inverse sine of 2x plus 1, right? I'm going to use chain rule. Yes or no? Yes. So first I want to find what? The derivative of inverse sine, and then we're going to times by what? The derivative of 2x plus 1, right? So what is the derivative of inverse sine function? This 1 over square root of 1 minus. We don't have x, we have what? 2x plus 1. So I would say, by using chain rule, y prime equals square root of 1 minus what? 2x plus 1 square, right? And times by what? 2x plus 1 derivative with respect to x. You agree with me? This is step 1. You guys? Alright, now let's simplify, okay? Let's simplify this thing under the square root. Oh, we have a 1, we have a minus 2x plus 1 square, okay? So how do we simplify this thing under the square root? 1 minus 2x plus 1 square. FOIL that give us what? By using the formula, right? Corner is what? 4x square. Yeah, 2x parenthesis square is 4x square. Plus 2 times by 2x times 1 give us what? 4x plus what? 1 square is what? 1. Yeah, these are the FOIL, the result from the FOIL of the square, right? And times by 2x plus 1's derivative. 2x derivative is what? 2. 1's derivative is what? 0, right? So I am going to write this 2 on the top of the fraction. Right? Okay, now let's see. 2 over square root of, careful, distribute negative 1 to each term. 1 minus 1, 4x square minus 4x minus 1, right? Like terms? Any like terms? See any like terms? 1 and negative 1, gone, right? So we have a negative 4x squared minus 4x. On the top we have a 2. It says simplify where possible. So I would say there is a 4, right? Pull the 4 out. Negative x minus x, parentheses. What is square root of 4? 2. The square root of 4 is 2 cancel out with this 2, right? So I would say 1 over square root of what? Negative x squared minus x. Done. Am I doing too fast? Square root of 4 is 2, right? That 2 cancel with this 2. But everything else must still under the square root. So that's why we have a square root of negative x squared minus x. Let me run for one more step. Some of you guys are still confused. So I'm going to write it here. Equals 2 over. Square root of 4 is what? Square root of 4 times by square root of negative x squared minus x. What do you think? This way. Square root of 4 times square root. Square root of 4 is 2. These two canceled. So that's how we get this, right? Yeah, this question is for inverse sine, right? Now the next question. Capital F is defined by x times inverse secant of x to the cube. Find the derivative of capital F. We have x times by inverse secant, right? So at the first we're going to use what? Product rule, right? Product rule. So this is product, right? So product, use product rule, okay? So product rule is telling us differentiate x, give us what? 1. And then we copy whatever is given for the other function, right? Plus what? Keep the x, and then differentiate what? I'm going to write it this way, okay? I'm going to differentiate the secant, inverse secant of x to the cube. I want to do it this way, because otherwise, you feel confused, okay? So this line is by using product rule. You guys, everybody? Okay, now the first term is the secant, inverse secant of x to the cube, and then plus x times by, okay? What is the derivative for inverse secant of x to the cube? What is inverse secant's derivative? Inverse secant x. Derivative is 1 over x times by square root of x squared minus 1. Right? So what is our inverse secant? Do we have an inverse secant of x? No. We have an inverse secant of what? X to the cube. So consider our, the x in the formula is what? X to the cube this time, right? So it is what? 1 over x in the formula should be replaced by what? X to the cube times by square root of x squared, x cubed square, what? Minus 1, right? And don't forget, this is a derivative of inverse secant. We have to differentiate what? X to the cube by chain rule here, right? The inverse secant's derivative is 1 over x cubed square root of x cubed square minus 1. Don't forget to multiply by what? X cubed's derivative. This is a tricky one, right? Tricky one. Alright, so inverse secant of x to the cube plus x times by 1 over x to the cube times by, what is x to the cube square? What is x to the cube square derivative? Right? And this x is x over 1, this is 3x squared over 1, right? So this is the entire term, okay, entire term. Are we able to simplify this x squared, give us x to the cube, cancel out with this what? X to the cube, do you see that? This x to the cube, square, and then cancel out with this x cube. And now on the top, we only have what? 3. On the bottom, we only have what? Square root of x to the 6 minus 1, right? So let's write for one more step. Inverse secant of x to the cube plus what? 3 over what? Square root of x to the 6th power what? Minus 1.
Is it important that we put cotangent, cosecant, and secant on our formula sheet, or?
Yeah, you want to put everything on it, because even for me, I have to think about, what is inverse secant function? What is the derivative? I have to think about it. These are more commonly used. The first 3 are more commonly used. See, this question, we talk about inverse secant. You better to put the formula on the formula sheet in order to use it, right?
Could you move down so I can see the other three then? I'm sorry.